Today's time waster project is this early to mid-60s Arvin AMFM tube radio. As you can see, it's beat up and filthy, but maybe if I get it working I can clean it up and get it looking a little better. This thing is totally dead, or I say totally dead, it's almost totally dead. Tubes light up, but that's it. I don't know how well, really can't see too well down in there, but take my word for it. Tubes light up, not a bit of sound, so let's open it up and see why. This particular set uses a silicon diode rectifier instead of a tube, and generally when one of these types of sets has tube filaments glowing but nothing else, I usually look in the power supply and in the audio output stages. First I'll check the B+ voltage on the primary of the audio output transformer. Okay. And as you can see, we have absolutely no B+ voltage on either side of the transformer. So now we will look in the power supply. There's our silicon diode right behind that fusible resistor. So let's check our voltage at the cathode of this diode and see if we have anything. And we have absolutely nothing. And we have our digital multimeter set to the diode test function. I'm going to test this diode. A good diode should read when the probes are connected one way, and then I should get infinite reading the other way. So let's see what we've got. 0.038 volts across that diode. I'd say that diode's shorted, and just to prove my point, let me reverse the meter. Our meter leads are reversed. Yeah, this diode is shorted. And most likely this fusible resistor will be open too. And checking across our fusible resistor, no surprise, it's wide open. So now I will remove the defective diode and resistor and find suitable replacements and see what happens from there. And here are the two parts, the fusible resistor and the diode. Unfortunately, the fusible resistor doesn't have a resistance value printed on it. All it has is a series of numbers. So without a schematic handy, I'll have to guess an appropriate value, which probably shouldn't be too difficult. Okay, I've now replaced the rectifier diode and resistor. Let's see if we get any reception. I bet we will.
I'm instantly connected to trained Acadian dispatchers at the touch. It goes with me wherever I go.
How about that?
While shopping and
or go to www.ncpc.org/getreal. That's ncpc.org/. So if you don't mind, I'll give you a quick.
Let's see if FM works. Okay, what's going on here? Switch is dirty. It appears we have no FM reception. Let me clean this switch and see if that makes a difference. Okay, got some FM reception, but it's very, very touchy. I believe the problem is intermittently shorted plates inside of the tuning condenser. Because now I've lost it. And now I'm hearing nothing but static as I rotate the tuning.
In connection with a one-based.
Yeah, that sounds like shorted tuning capacitor plates. So let's see how I can get inside of this FM tuner module and clean them. One thing I'm noticing is that the solder connections on this FM tuner module don't appear to be too great. So I'm going to resolder those and see if that improves the situation before I attempt to disassemble this FM tuner module. Resolder the band switch assembly as well as the FM tuner module. I will fire it up and see if it makes any difference. Okay, resoldering did absolutely no good. I was able to play with it and get it to tune in a station, but if I touch it, away it goes. And pretty much all I get is static, which I'm going to have to tear into that tuner module and see what's going on. Okay, this is a rather strange FM tuner arrangement that I don't believe I've ever run into before. It appears that these set of contacts here, and this set of contacts, and these set of contacts, and these set of little contacts here make up the capacitor, the variable capacitor. And it looks like this might have had some insulating varnish over these traces at one point that has now worn off, and that could be the reason the contacts are shorting to one another. At the moment, I'm just going to try to clean this the best I can and see what happens. And if that doesn't solve the problem, I'll try to come up with some type of insulating varnish to recoat these traces. But we're really not out much anyway, because this is sort of a turd of a radio, so if it works, great. If it don't, then that's fine too. So I'll try cleaning it now.
A band T-shirt that no one can use.
Okay, I cleaned it, and it's better, but it's still nowhere near where it needs to be.
There's, perhaps later we'll talk about mosh pits and things like that. I stay out of those just because I like my teeth. But I sometimes
marriage advocates are seeking, and they're necessarily not associated marriages. My point is not to urge evangelicals to abandon birth control, which I think is morally defensible, but to raise the very important question of how we have chosen to embrace it.
AFC turned on, possibly.
Last month, Ozzy admitted, for the last year and a half I've been drinking and taking drugs. I am now 44 days sober.
See, it's very touchy towards the high end of the dial. Yeah, I did some more cleaning on the FM tuner contacts, and it's better, but we still have a ways to go. Okay, I've cleaned the tuner about as well as I can. I also replaced the electrolytic capacitor can, which had a weak section. I also replaced an electrolytic capacitor in the FM detector circuit that was almost dead. And the original design had the AC running straight into the rectifier diode with no surge resistor. I added a 3.9 ohm resistor between the AC line and rectifier input, so that's kind of softened the blow a little bit, but it works pretty good.
Blue shift as everything withdrew to one single point. You're telling me that works? Absolutely.
Still have to restring the dial.
And our borders.
Alfalfa hay, it was.
On the buzz. Thank you. How about that? Is that reasonable?
Something by Prince that you don't hear on the radio much.
Say she was a sex fiend. I met her in a hotel in masturbating magazine.
Let's try AM. Turn the light off.
Members fringe hate and 11:06 every morning on Atlanta's news, weather, and traffic station. News Talk, WSB. Depends on it. Hate is now part of the everyday political discourse in America. And the pathetic truth is that the Florida area and it my ways.
Okay, it's ready to have the dial restrung and put back together. Okay, here it is back together playing for whatever it's worth. I really have to say this particular tube radio ranks right up there with some of the shoddiest construction that I've ever seen, but there it is for what it's worth. Thanks for watching and more to come later. This is Radio TV Phono Nut, and we have a Bulova power transistor AM clock radio from probably the mid-60s. I don't yet know who actually built this, but I suspect it might have been built by Arvin. I know they built other radios for that company. Looks in decent cosmetic shape. Let's turn it on and see what happens. Bad filter capacitor, as you can hear. I'm not getting any stations as I tune across the dial, so let's address one issue at a time here. And here we are with the back cover removed. Here's the chassis. This is the typical line-operated chassis that does not use a power transformer. They're running the audio output stage off of about, probably 80, 90, or 100 volts. And then the rest of the stages are operated from a low voltage provided by a big dropping resistor. And here's the big orange filter capacitor that's bad. Now, one thing that's strange is notice the antenna. This is the first solid state set that I recall seeing that uses a traditional style loop antenna like what you'd see in a tube set. Up until now, everything I've seen used a ferrite bar antenna. Okay, let's get it apart, replace the filter capacitor, and then see where we need to go from there. Here's the old capacitor, a dual section 40 microfarad and 100 microfarad and 150 volts. And this is date coded 1965. As you can see, I replaced it with two modern individual capacitors. Now we'll apply power and see if we can get any reception. Well, that took care of most of the hum, but still nobody home in the station department. So what could be wrong with the radio? Any stage in the receiver could fail and cause the problem that we're having. So the best way to determine what's wrong is by process of elimination. We'll start at the audio stage, and the quick way to confirm whether or not it's working is to touch the center terminal of the volume control. And if we hear a loud buzz in the speaker when we touch that particular terminal, then that will tell us that the audio driver stage and output stage is working. If we don't get a buzz, then we'll know to concentrate our efforts in the audio stage. And I think we still have another bad electrolytic in here. We shouldn't be getting that much hum. And I'm touching the center terminal of the volume control, and I'm not getting diddly squat. So let's pull it all apart and see what's going on with it. Let's check our voltage on the output transistor. We'll start with the collector. 37 volts, that seems a little low. And looking at the emitter, 22 volts, don't look right. And the base, 31 volts. Could we have a leaky audio output transistor? Okay, here's our audio output transistor, a TO66 packaged device. I believe it cross-references to an NTE124. That was pretty much the standard output transistor used in these types of radios, but we should be able to find one around here somewhere that will work. Now I'm going to demonstrate how it tests. The black lead will be our base terminal, the white lead will be the emitter, and the case will be the collector. And one thing I'd like to mention, with most of these types of radios, the heat sink that the transistor is attached to is normally the collector terminal. It is not ground. A lot of times in many sets the heat sink is at ground potential, but in these 1960s, early 70s radios like this, that's usually not the case. So you want to double check that before you assume that the heat sink is at ground potential. Okay, now let's do this. Okay, we have our meter set to the diode test function. We have the positive meter lead connected to our base terminal of the transistor. We have our negative meter lead connected to the collector. And we're reading 0.66 volts. Well, that's good. Now we'll reverse the leads, and if this is a good transistor, we should read nothing. Okay, I reverse the leads, and I get absolutely nothing. So far, so good. Now we have our positive lead back on the base, and our negative meter lead on the emitter. 0.67 volts. That's good. Now let's reverse the leads and see and we get nothing. Now I want to check between emitter and collector, and I should get nothing both ways. Positive meter lead on the collector. Negative meter lead on the collector, positive on the emitter, and I'm getting 0.1 volt. It's not good. Now let's reverse the leads. Leads are reversed, and I'm getting the same thing. Just out of curiosity, let's see how many ohms this junction reads. And resistance-wise, we're reading 60 ohms between emitter and collector. So that's where the fault of this transistor lies. Now, if this were a germanium transistor, our voltage that it would take to turn the device on would be about, in the range of 0.2, 0.3, somewhere around there. With a silicon device, it's usually around 0.5, 0.6. And with some germanium transistors, you will get a reading when testing from emitter to collector, but it should not test shorted. I don't exactly know why that's the case, but I've seen that happen most times when testing a germanium transistor. Now, this is an NPN transistor, which means you'll get a reading if the transistor is good when your positive lead from the meter is placed on the base and the negative on the collector and then the negative on the emitter, etc. Now, if it was a PNP transistor, you would get a reading with the negative meter lead placed on the transistor base and the positive lead placed on the collector and then the emitter, respectively. But in no circumstances should you get a reading both ways. You should be able to reverse the meter leads and you not have any reading on your meter. Okay, let's try to find a transistor that will work in this set. Okay, I was unable to find the correct part, but I found this ECG 228A, which is a general purpose NPN AF and video output transistor, and looking at the specs, it should be more than adequate enough to handle this little radio application. You can see how I have it mounted there, and I have leads attached and insulated with heat shrink tubing to connect the device to the circuit board. And yes, I did use heat sink compound on the transistor mounting. This is our collector pin, which is connected to this tab here. Before I complete the repair, I will make a solid connection to the collector terminal on the circuit board. I won't rely on just that bolt and heat sink for the connection. So let's fire it up and see what it does, and I'm going to bring this up slowly on the variac in case something's not right. Maybe I can catch it before I cremate this transistor.
Around for it, really let those catch it.
Okay, we're at about 60 volts AC input, and you can hear the results.
Usually wakes up at 4:30. Then we go for a walk. He needs lots of attention. I do need to keep an eye on his medication, so that's important. Sometimes I feel like a phone.
I think we have a loose connection somewhere.
Everybody knows why.
Yeah, it's WSM, but we've got an issue with the volume control. It's as low as it'll go, and it's still not down, so probably going to have to replace that.
Panic disease. Reduce or just be urine.
Guys, if you see a technical here for Briscoe, because he was travel timeout 3:17.
Group called Concerned Student 1950 interrupted.
Whatever went on, I promise you.
It was 12. Hallándose. The Beechwood Age Budweiser Draft.
And the Spurs will take a 9-point lead in the locker room. The halftime score is San Antonio 53, Detroit 44. This half of Spurs basketball has been brought to you by Frost Bank. Expect more from Frost. Visit frostbank.com.
Local station, it's coming in way too loud.
It starts at 9:05 at Magnolia Restaurant inside Queen City.
He knows it as well as you.
But as you can hear, this thing is very sensitive. Just need to fix the volume control and we'll be ready to call this one done. Okay, this looks like a bad connection issue because in this position it's quiet. I let it go and the volume goes up. So let's look at these wires where they solder to the printed circuit board and make sure they're soldered securely. Yep, there was the bad connection right there. The ground side of the volume control.
Decker, Fox News. South Carolina Governor Nikki
Okay, that ought to do it.
GOP's
Don't have to replace the volume control. It gets quiet now. And by the way, that hum that we were hearing after we replaced the filter capacitor was a result of this transistor being leaky. So, yeah, I think the transistor is probably what sent the radio to the closet. And then the radio sitting in the closet for 20 or 30 or 40 years caused this filter capacitor to dry out. But we ought to be good to go for another 40 or 50 years, hopefully.
President Obama should communicate to the IRS.
Right now, he's always been ignored, but right now... with a triple. Roasting, you're sure to score big at the family dinner table with any of our H-E-B fully cooked meats. In fact, nothing says Texas better than H-E-B fully cooked brisket. It's smoked for 18 hours, the true Texas way. It's sure to be a game winner at your next family dinner.
Everyone likes data, because when you have more data, you have more freedom. Freedom to do whatever. That's why AT&T is up for the shot clock.
Okay, there you go. Thanks for watching, and more to come later.
WSOnline.com. Queen of Hearts, that's Juice Music tonight.